Good afternoon. We're going to finish off 16.2 notes. This is part 2, and it is about entropy. So we have entropy is a measure of the randomness or the disorder of the system. It's actually a probability thing, and I have an amazing article that I'm going to send you guys to read. It involves sheep, so check that out. It is the actual definition of entropy, but we can think of it as the randomness or the disorder of the system. So, example, if we had solid salt, you guys know what that looks like. That's a crystal lattice, so a repeating pattern of positive and negative ions. And when they are all nice and orderly like this, we say that it has low entropy because it's very organized. So it has low disorder. Once we dissolve that into water, all of these break apart and they move around randomly. So when the positive and negative ions are floating around freely wherever they want, they can be randomly dispersed, they can move. That would be high entropy, okay, because they are randomly dispersed. So they are very unorganized. The second law of thermodynamics says that the entropy of the universe is always increasing. So your bedroom, for example, it's going to naturally tend towards disorder. If you want it to be nice and organized and neat, you have to fold your clothes, you have to dust your furniture, so you're going to have to add energy to reverse that process and change the entropy of your surroundings. Okay, so second law, everything is tending towards disorder. You put the following in order of increasing entropy, so stop and do that really quickly. Okay, so increasing entropy means we're going to start with low disorder. Ice is the most organized form of water, then water, and lastly steam is the least organized because the molecules are moving the fastest and they are the most random. So steam is the highest entropy. Sand, boulder, and pebbles. So the most organized of those three would be the boulder. There's not a lot of ways for the atoms to be arranged in a boulder. They are fixed in that position. Okay, pebbles are slightly more organized, pebbles, and then sand would be the most random. So that has the highest disorder. They're all mixed up and they can be in any arrangement. Okay, if delta S is negative, the entropy is decreasing. So we can think of it just like our energy diagrams up here. We can have entropy diagrams. If the entropy is decreasing, that means the disorder is decreasing. Okay, you have to kind of think backwards about this. If the disorder is decreasing, it's becoming more organized. So this would be, for example, steam condensing into liquid water. It's becoming more ordered. So the disorder or the entropy is decreasing. Okay? If delta S is positive, delta S is negative. If delta S is positive, then the disorder is increasing, and that's actually a favorable reaction. So if it's becoming less organized, it's more likely to happen spontaneously on its own without added energy. So this is entropy. Entropy is increasing here. So we're going to end up with something that's more random. How can we tell if that's happening? Well, if we look at our example right here, it's pretty easy to see that we have a solid, okay, on the left. So this is a very highly organized substance turning into two different gases and a liquid. This side has much more randomness going on. So the entropy is increasing. So we have this going on. So delta S is going to be positive in that example. Okay, and this is just a summary of what we just said. For free energy, there's very little that we need to go over right now. There is a thing called delta G, Gibbs free energy. Remember that this naught means standard state, which depends on what you're talking about, 1 molar or its natural state at room temperature and pressure. This is how we calculate it. We know delta H is the change in enthalpy. T is temperature. Delta S, we just discussed, is the change in entropy, and we can calculate delta H this way. We won't actually calculate it, but that's how you do it. Okay, so down here, what we need to know is that if delta G is negative, the reaction is said to be spontaneous or thermodynamically favorable, is the way that the AP test puts it. So thermodynamically favorable means spontaneous, means it will happen all on its own, and we want delta G to be negative. All right, thank you guys. Have a wonderful day.